So here are the solutions for the Chapter 1 review homework. In our first grouping of problems, we were asked to find whether each equation was a function or not, and then if it was a function, find its domain and range. So number 1 is y equals the absolute value of 3x plus 2 minus 4. This is a function. It has no restrictions on its domain because it has no fractions or even indexed radicals. However, this graph is transformed and it is moved down 4. So the y values would be strictly greater than or equal to negative 4. Number 2 is the equation of a circle. So we didn't even have to find the domain or range. Number 3, square root of x squared minus 7 does pass the vertical line test. Its domain is going to be from negative infinity to negative square root of 7, including negative square root of 7, and then start up again, square root of 7 out to infinity. Again, if you're using your calculator for this, you're going to get decimal approximations to these. And this is actually the top half of a side-by-side hyperbola. So the y values that are being used here are only greater than or equal to 0. And number 4, even though it's a fraction, does pass the vertical line test. You cannot use an x value of 5 because that would make the denominator go to 0. And then when I solve the equation for x, which is what you have to do for fractions, I can see that if I put a y value of 3 in the denominator, it makes the denominator go to 0. So I can't use a y value of 3. Later on in chapter 2, we learned about horizontal asymptotes. And if you look at the leading coefficients here, they have the same highest power of x, and the ratio is 3 to 1. So the horizontal asymptote here is y equals 3. But we didn't know that in chapter 1 before when we were doing this. For the next grouping of problems, you were asked to find the relative mins and maxes and list out the intervals for increasing, decreasing, and constant. So we have a relative minimum right here, and that is a point that's at negative 6, 7. We have another relative min right there at 4, negative 1. And we have a relative max right here at negative 3, 5. You can have more than one relative min or max, and be careful. If it's not an integer value, you might have to use your calculator, but we weren't even given a formula for this. So it's at integer value too. This graph is decreasing from here to here, and also decreasing again from here to here. So it's based on x values from negative infinity to negative 6, and also again from negative 3 to positive 4. So that's decreasing. It's increasing from here to here, and from here to here. So from negative 6 to negative 3, and positive 4 out to infinity. Never include the ends. Interval notation, if you have more than one interval, you have to say the word or in between them. On the top of the next page, we were asked to say whether or not these functions were even, odd, or neither. So you could do this either by plugging a negative x into your formula everywhere for x and doing it algebraically, or you could be graphing these functions and seeing if they have the different kinds of symmetries that we're looking for. So number 1 is a neither. Number 2 is odd. It has symmetry over the origin, or all the x values change when you plug in a negative x. Secant is one of the even trig functions, so this one's even. And number 4 is neither. So for the next grouping of problems, we were asked to make a graph for each one of these equations. So number 1 is a parabola. It's been flipped over the x-axis. It's been vertically dilated by a factor of 3, moved 2 units to the right, and then up 4. So you can do that in stages, but this is what the final graph is going to look like. Its vertex is going to be at 2, 4, and it's going to be headed downwards. It's been stretched. Number 2, remember, if you have a reflection in the y-axis, or if you have a horizontal dilation, or if you have both of those, you got to get that factored out. It looks like you're going to move left 6, but you're not. You're actually going to move right 3. So make sure you get that factored out. It's a square root graph. It's going to be backwards because of the reflection over the y-axis. It's going to be horizontally compressed. It's going to be moved 3 to the right and then down 1. So there's what the picture should look like. Number 3 is an absolute value. It's going to be upside down. It's going to be vertically stretched by a factor of 1/2, which actually means it's shrinking. It's being moved left 5 and then up 3. So this is what your final picture should look like for that one. And the last one in this group said they actually gave us a picture. And they said, well, what equation made this picture? So first of all, I want to identify the shape. It's a parabola. Then you're going to notice that this parabola is upside down. You're going to notice that the vertex for this parabola is at negative 3, 7. So it's been moved left 3, and it's been moved up 7. But then the one other thing, and this is really subtle, so you got to be very careful to notice this. When you move over 1, this graph does not move down 1. I know it's upside down, but it actually moves down 2. When you move over 2 units horizontally, this graph is actually moving down 8. Well, that's actually double of what it's supposed to be doing. So I can tell that this has been vertically stretched by a factor of 2. So upside down, vertically stretched, move 3 to the left, and up 7. In the next grouping of problems, they gave us 2 formulas, f of x, which is 3x squared minus 2x plus 5, and g of x, which is 4x minus 7. And they were going to ask us to do some different things using function notation. This is a combination using subtraction. Subtraction, the order matters. So function f has to come first, and then we're subtracting function g. So then you just subtract the 2 formulas. You're going to get 3x squared minus 6x plus 12. This symbol right here is multiplication. So they want you to take the formula for the function f and the formula for function g, and they want you to multiply together. Make sure you go through that distribution process. Everybody in the first set of parentheses is going to have to get multiplied with everybody in the second set of parentheses. That's actually 6 multiplications, and you're going to collect like terms. And you're going to get 12x cubed minus 29x squared plus 34x minus 35. This symbol right here is composition, and that means the formula for g is going inside of the formula for f. So use parentheses whenever you're replacing the formula for g in place of x. You're going to have to FOIL this out, then distribute the 3. Then you're going to have to distribute the negative 2 through these parentheses, then collect like terms. You're going to get 48x squared minus 176x plus 166. And the last one is a composition. This time they want you to put formula f inside of formula g, and they want you to evaluate at negative 3. Now there's a couple different ways you can do this. I actually decided to put the negative 3 into formula f and evaluate. So negative 3 is going to get squared multiplied with 3. Negative 3 is going to get multiplied with negative 2 and then add 5. This all works out to be 38. And then once you get that 38 is going to get put in as the x value in the formula g, which turns out to be 145. The last one in this grouping was finding the difference quotient of formula f of x. So f of x was this quadratic right here, 3x squared minus x plus 5. You have to evaluate that at x plus h. So putting x plus h where the x's go into this formula right here, here, and here. You're going to have to FOIL this out, multiply 3 by 3, distribute the negative 2. Then you're going to have to subtract the original function from it. So you get this entire big, long, crazy numerator. And then a lot of the stuff here cancels out. 3x squareds cancel out. The 2x's here cancel out. The minus 5 and the plus 5 cancel out. So all the things that are left have h's in them, which is nice because you have to divide by h. Final answer here, 6x plus 3h minus 2. And that represents your instantaneous rate of change, which is what you get from the difference quotient. In the next 3 problems, it said if the function is a one-to-one function, find its inverse. If not, state the restricted domain, then find the inverse. So problems 1 and 3 were one-to-one functions. They passed both the vertical and horizontal line test, so you can immediately get into the x's and the y's, and then resolving the equation for y. Remember, when you get done with that, you're going to want to label that with f to the negative 1 of x to let people know this formula is for the inverse. It's not the original function anymore. Problem number 2, however, was a parabola. And I could tell that because it had the squared on the x terms right here. So parabolas do not pass the horizontal line test, so you're going to have to restrict the domain. I chose to keep x's greater than or equal to 3. That's the right side of this parabola. You could have chosen to keep the left side of the parabola, and your restriction will be x is less than or equal to 3. But if you do that, that makes your job harder. Keeping the right side of the parabola is going to make your job easier. If you switch, now that we've made that restriction, now we are ready to switch the x's and the y's in the formula, and then resolve the equation for y. That means you have to add the 4 over to the other side, divide by 2, take the square root of both sides. This should be, now, when you take the square root of both sides, normally you'd get a plus and a minus. Because we've kept the right side of the parabola, we're going to get the positive square root of this. If you had kept the left side, if your restriction was x is less than or equal to 3, you need a negative out in front of here, and that's tougher to remember. And then, by the way, the last thing you'd have to do to get y by itself is add the 3 over to this side. This will be the formula for my inverse. If you had x is less than or equal to 3 as your restriction, you need a negative out in front of the square root. And the last part of this group right here is they wanted you to prove that these two functions are inverses of each other. So you form their composition by putting the one function next to the other. Show me how it simplifies step by step. You have to show all these steps and show me that the answer turns out to be x. Now remember, composition is not a commutative process, so once it works one way, you're actually going to have to do it the other way around, putting f inside of g, and again, showing me the answer works out to be x. Again, show every single step of this math, and you have to be doing your orders of operation in the correct order. I would be checking that if I asked you a question like this. For our last grouping of problems, we were going to be taking a look at some of the non-functions or possibly non-functions. And remember, if you're being asked to decide what kind of graph you've got, you're going to want to get your x's and your y's on the same side. So I'm going to want to bring these 3y squareds over to the left-hand side where it becomes negative 3y squared. I noticed that we have x squareds and y squareds, but we have different signs. That makes it a hyperbola. If you were to bring, well, actually, if I were to bring this over to this side, I guess it wouldn't matter because this only has x squareds. The y's are not squared. That means it's a normal parabola. This one only has y squareds, and the x's are not squared, so that means this one's a sideways parabola. And this one, if you bring the y squareds over to the left-hand side, you're going to notice that they have the same side but different numbers. That means it's an ellipse. Now, the last two problems down here are asking you to describe the transformations that are applied to these sideways parabolas. So sideways parabolas are non-functions. You can see that the equations here are being solved for x, which is clearly the wrong letter to be solved for. So before you try to describe to me any kind of transformations, do not ever use a formula that's not solved for y. Rearrange these formulas, get it solved for y. For this one, I'd have to add the 7 over to the other side. Then I would take the square root, which means you need a plus and a minus in front of that. Then I would add 3 to both sides, and then I would multiply both sides by 2. So this is the equation that you want to talk to me about transformations with. We've got a vertical dilation, we've got a horizontal shift to the left 7 and up 6. And for this one, when you subtract the 4 which to your side, divide both sides by 3, and then take the square root, you got a 1/3 inside. That's your horizontal dilation, and a -4 next to the x, that's your moving to the right 4. These are the answers for the Chapter 1 review. Hope you did well on it.